All right, guys, we're going to move on to section 9.3. Now, if we were back in a normal classroom setting, this is one of those lessons that I know I would have to spend 2 days, maybe 3 days on, probably 2 to be honest. So we're definitely, in this kind of learning environment, going to spend a couple days on it, if not 3 days on it. Okay, don't put this one off. Your homework tonight is only 2 questions. Okay, or today. I gotta get used to not saying tonight every time. Your homework today is only going to be 2 questions. These take a little bit of time, right? It's not like a 30-second thing, maybe 2 to 3 minutes a piece. So your homework's not going to be crazy long or anything. But you'll have 2 of them tonight, and then when we come back for our next virtual day on Tuesday, you'll have a couple more, and I'll have another video of doing some more examples. All right? Please make sure you're taking advantage of office hours. I didn't have great participation today. Saw a couple of your faces, but this one, though, I think you're going to need to ask some questions about, whereas the other 2 assignments have been pretty straightforward and pretty easy. So please take advantage of that time. Let's go ahead and get started with this. Okay, when we graph one of these parabolas, we're going to find the axis of symmetry, which we learned how to do in section 9.2. And then we're going to graph 5 different points. We're going to graph the vertex, which we learned how to do in section 9.2. Today, we're going to learn how to find the y-intercept. Easiest thing ever, I promise. And then we're going to have to learn how to find a point symmetrical to the y-intercept. Okay, this might sound complicated, but if you can count, then you can do this. Hopefully you guys are in Excel math, hopefully we know how to count. So this should be pretty easy. And then I don't really have a fancy name to call this. I'm just going to say another point and the point symmetrical to it. So when you graph a parabola and you find one point that's not the vertex, any other point on the parabola, it's kind of like it's a BOGO, buy one, get one free. If you know where this point is, then you know where its symmetrical point is, because it'll be on the other side of the axis of symmetry. Okay, so I'll go into that in more detail, obviously. So axis of symmetry, vertex, the y-intercept is its symmetrical point, any other point, and its symmetrical point. Okay. Sounds complicated, but I promise it gets easier the more we go through it. All right, we have y equals 2x squared minus 4x minus 3. I've divided these problems into 3 slides each because I just didn't have enough room to write all this and do some math. It's tight as it is anyway, like this. So hopefully this will work. Best I can do here. Let's see. To find the axis of symmetry, we need to use our equation x equals negative b over 2a. Well, a is 2 and b is negative 4. So that's the negative of negative 4, or the opposite of negative 4, if you want to say it that way. And then 2 times 2, so we get 4 over 4, which is 1. Again, I overemphasize this because every year when kids take a test over this, they say the axis of symmetry is 1. And every year I take points off. The axis of symmetry is not a number, it is an equation of a vertical line. So it is x equals 1. All right, so I'm going to go ahead and draw in the axis of symmetry. Remember, when we do that, we're going to use a dashed line. I'm trying to draw through my shadow. It's more challenging than it looks. And I'm going to label that x equals 1. So there's the axis of symmetry. And now I'm going to find the vertex. Well, based on what we talked about yesterday, we know that the x-intercept, or the x-coordinate, is 1. Now I have to find the y-coordinate. So we're going to plug 1 back in. Might have enough room to do this. We'll see. 2 times 1 squared minus 4 times 1 minus 3. That's 2 minus 4 minus 3. that's going to be -5. So 1, -5. Okay, so I'm going to go ahead and plot my vertex. 1, -5, so 1, 2, 3, 4, 5, right there. 1, -5. Okay. So I got the first two things taken care of. And with any luck, the next slide, that graph will be in the exact same spot, and I won't have to redo anything. Let's see here. Looks like it worked. So now I have to find the y-intercept. The y-intercept occurs where the parabola crosses the y-axis. If you look on the y-axis, every single x value is 0. So plug 0 in right here. This goes away, this goes away. What are you left with? -3. In other words, the y-intercept is always equal to whatever c is. So in this case, the y-intercept is -3. So I'm going to go down and put the y-intercept there at -3. Kind of missed. Try that again. Yeah, it'll have to work. The y-intercept is 1 away from the axis of symmetry. So if we go 1 away on the other side, that would be the point symmetrical to it. Right? That's an axis of symmetry. So however far away on this side, it'll be another point. There'll be another point on the other side the same distance away. That point is 2, -3, so I'll fill that in. So finding those 2 points is pretty easy. Again, the y-intercept is just equal to c, and then that was 1 away to the left, so the symmetrical point is going to be 1 away to the right. Okay, let's look at what we're going to do to end it. All right, so we can start to see the general shape of this parabola. Okay, it'll go through there and come back up. What we want to do is pick any x value that we think will be on the graph. Now, I wouldn't pick like 10 because that's going to be way up above. That'll be off the graph. So right here, x is 0, so maybe let x be -1. Or right here, x is 2, so go 1 over and let x be 3. Whichever one you want to choose. I would rather work with -1. That's a really easy number to work with. So I'm going to let x be -1. Substitute that x value into the equation. So I get 2 times -1 squared minus 4 times -1 minus 3. Square -1, you get +1. Take that times 2, you get 2. -4 times -1 is +4 minus 3. 2 plus 4 is 6, minus 3 is 3. So I have an x value of -1, a y value of 3. The coordinates of that point are -1, 3. So go ahead and plot that on the graph. -1, 3. That is 2 away from the axis of symmetry. So if I go 2 to the other side, I'll get the symmetrical point, which is right there. The coordinates of that are 3, 3. And the last thing I need to do is draw in my parabola. There we go. I have my axis of symmetry, the vertex, the y-intercept, its symmetrical point, any other point, and its symmetrical point. I have my 5 points. A lot of steps. It's one of those things, though, that you're just going to take a little bit of practice for you to get used to it. I'll have to make sure and remember to upload that blank graph paper. So if you guys are fortunate enough to have a printer at home, you can go ahead and print and use the graphs from that. All right, next one, we have y equals the negative x squared minus 6x minus 2. So this time we'll have a parabola that opens down. I can tell that because the a value is negative. All right, so let's start out by finding the axis of symmetry. In order to do that, I need to know a and b. A is -1, b is -6. So start with our x equals -b over 2a formula. That's the opposite of -6 over 2 times -1. It's +6 over -2, that's -3. So the axis of symmetry is x equals -3. And let's see, 1, 2, 3, so let me put my dashed line here that I can't see. Close enough. Now I have to plug -3 back in order to find the y coordinate. Again, I already know the x coordinate is -3. So let's plug -3 into the equation. And y equals the negative of -3 squared minus 6 times -3 minus 2. Square -3 and you get 9. Drop that negative and it's back to -9. -6 times -3 is +18, then minus 2. -9 plus 18 is +9, minus 2 is 7. So we get -3, 7. So let me go ahead and plot that. 1, 2, 3, 4, 5, 6, 7. So right in there, we have -3, 7. And the equation of that was x equals -3. Okay. So we have our axis of symmetry and we have our vertex. Let's now go ahead and find the y-intercept and its symmetrical point. The y-intercept is equal to c, so that's -2. So that would be down here. That is 3 away, so go 1, 2, 3 on the other side. And there's the symmetrical point. The coordinates of that point are -6, -2. So those are definitely the two easiest points to find. There's not a whole lot of math there, just a little bit of logic. And let's move on to the next one. Okay. We know that this parabola is going to be here and go down on this side. This is -3, this is 0. So as it drops down, it's going to have to go through -2 and -1. Those are the values I would work with. You could also work with -4 and -5, but those are bigger numbers, so you're going to have to deal with bigger numbers. Again, I would use -1 in this case because it's a small number and you know it's going to be on this graph. There's -3, there's 0. It has to go across an x value of -1 in between there. So let's let x be -1 again. We're not going to always use -1. We just have the first 2 times. So let me substitute that in. I have y equals the negative of -1 squared minus 6 times -1 minus 2. Square -1, I get +1. Drop that negative on the outside, I'm back to it being -1. -6 and -1 are +6 minus 2. -1 and 6 is 5. 5 minus 2 is 3. So x is -1, y is 3. -1, 3. plot that point, -1, 3. It's 2 away from the axis of symmetry, so let me go 2 on the other side, and that would be this point right there. And the coordinates of that point are -1, 2, 3, 4, 5, -5, 3. So there's my 5th point I'm looking for. Let me draw in the parabola. Kind of missed my dots, but good enough for what we're doing today. I'm not going to redo it. All right, I got one last one. I had to bring up one of those evil fractions that we can work with here. A is 1/4, B is 2, so x equals -b over 2a. That's going to be -2 over 2 times 1/4, -2 over 2/4, or 1/2 I should have wrote. We can fix that. And then dividing by 1/2 is the same as multiplying by its reciprocal, which is 2. So I'm going to get -4. So the axis of symmetry is x equals -4. So let me draw that in. And this one's going to open up, so I'm going to write that on the bottom. X equals -4. So plug in -4. Get y equals 1/4 of -4 squared plus 2 times -4 minus 4. If I square -4, I get +16. Take +16 divided by 4, I get 4, minus 8 minus 4. So 4 minus 8 is -4. -4 and -4 make -8. So my vertex is -4, -8. So there's -10, -9, -8. -4, -8. There's my vertex. So all that should be reviewed from section 9.2. So hopefully we're good there. The y-intercept is going to be the c value. In this case, that is -4. So let me put that on there. -4. I'm 4 away, so I got to go 4 the other way. 1, 2, 3, 4. The coordinates of that point are -8, -4. So we have those. And lastly, we want to find any other point and a point symmetrical to that. Now, we have to be a little bit careful because of this fraction. We got to make sure, in order for it to have a nice, neat number at the end, that whatever we square is divisible by 4. In other words, I don't want to pick 1 because then I have to take 1 divided by 4 and I have a whole mess there. What I would pick is this is -4, that's 0. -2 is in between there. You square -2, you get 4, and obviously that's going to be divisible by 4. Or you could pick +2 over here, This one's going to go past that. So I would either use positive 2 or negative 2. I'm going to let x be negative 2. So plug that in. You get 1/4 equals negative 2 squared plus 2 times negative 2 minus 4. Square negative 2, I get positive 4. Take that and divide it by 4, I get 1. Minus 4 minus 4. 1 minus 4 is negative 3. Negative 3 minus 4 is negative 7. So I forgot to put... No, I didn't. That's negative 2 and that's negative 7. So there's my other point. Negative 2, negative 7. Negative 2, negative 1, 2, 3, 4, 5, 6, 7. That's 2 away, so go 2 to the other side, and I get this point right here. That's the symmetrical point. And the coordinates of that are 1, 2, 3, 4, 5, negative 6, negative 7. And the last thing to do is draw in that parabola. There we go. There's 3 examples. Hopefully that was enough for you guys to get the hang of it. Like I said, you only have 2 of them to do on your homework. Actually, the worksheet I'm going to share with you has 4 of them, but the homework is only to do the first 2. If you struggle with this a little bit, don't be alarmed, don't give up, don't get frustrated. Typically, this is one of them where, like I said, if we were in a normal classroom setting, it would be one of them where you guys would find me in the hallway 10 minutes before class and tell me how hard it was and tell me you hope I don't take a grade and all that other kind of stuff. So some of you are going to struggle with this. Make sure you come, log on to those office hours, take advantage of that time, make sure you can ask questions. All right, that's it. Let me put the homework slide up there. This says if you have a printer, the best thing to do is probably print it out just so you have that graph to work on. If you don't have a printer and you have to draw your own graph, it's not the end of the world. I was taught algebra 20 years ago, back in the horse and buggy days, and I didn't have a graph. I had to draw my own. I made it. You're tough enough. You can make it. I think we'll be okay. All right, I'll see you guys hopefully during office hours tomorrow. Have a good one.